with our order of operations, and I'd like you to stop the video, try problems A, B, and C for warm-up to see if you can remember what we did back on Friday. Stop. Okay, so something that you need to remember from Friday is the unwritten index is 2, so I need to know my perfect squares. My perfect square of 144 is 12. 2 divided by 2 is 1, so there's an x that comes out. 4 divided by 2 is 2, so there's a y squared that comes out. 8 divided by 2 is 4, so there is a z to the 4th that comes out. Everything's out. That's my answer. So now with 98, off to the side if you need to. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, and that's all the farther I need it for this problem. So 98 would fall in between them. I'm keep looking. I see that this is the square root of 49 times the square root of 2, and then all of the exponents behind it. Square root of 49 is 7. The square root of 2 is going to stay on the inside. With my division of the exponents, the 4 divided by that understood 2 on the outside gives me an x squared. Y to the 7th doesn't divide evenly, but 7 divided by 2 has 3 for a whole number, and then there would be a remainder of 1, so there'd be 1 on the inside. And 31 divided by 2, that gives me z to the 15th out here, and then there would be a remainder of 1 on the inside. Okay, so continuing to work on my perfect squares that I'm supposed to know. After 100 comes 121, and then it comes 144, 169, 196, and 225. Now, none of the 242 is after the 225, so I'm kind of looking at what would give me something to give me 242. I look at the 121, it would go into it, so there's going to be a negative sign, the square root of 121 times the square root of 2, and then we'll deal with the exponents. So the negative sign comes down, 11 is on the outside, root 2 is on the inside. 3 divided by 2 gives me an A, and then there would be a leftover A. B, I can't divide anything out, it stays on the inside. C, 7 divided by 2 is 3, so there's a C cubed out here, but then there'd also be a remaining C out there. So that is just kind of doing a review of what we talked about on Friday. So as we continue to move through these notes, notice our learning targets for today. We're going to be able to simplify radicals. We're going to simplify expressions. Calculator we did on Friday, so I'm not going to review that, and multiplying radical expressions. So I am going to tell you to go look at day 1 notes. Okay, and remember that there is a square root key, and then there is a key that has a box, a square root, and a box in it. This one will allow you to do those types of problems. Okay, on to the fun stuff. On to the operations with radicals. So we are going to be able to add and subtract radicals if they are like terms or like expressions. And the only way that they are like is if everything is exactly the same. Notice on the inside it's a root of 3b and it's a root of 3b. Here it says I have 2 of them and here I have 1 of them. Here, this is a square root of 3b, but this index changed. These are unlike terms. And unlike terms, notice on the inside there's a 3 and there's a 5. That means that those are different bases. So we need to kind of watch those types of things. So when you are adding and subtracting expressions, to add and subtract, the one thing that I want to tell you to do is I want you to simplify each term first, meaning do what we did on Friday. We need to simplify. Once we simplify those, then we are going to combo the like terms. Okay, so for this first problem, oops, I'm going to change colors. I see square root of 45 would be 9 times 5. And there's already a 3 on the outside, so that outside 3 stays. The square root of 9 is another 3 that's on the outside, and the inside would stay root 5, turning into 9 roots of 5. Okay, so now 80. So I'm thinking back to that list that I made up on the top. 80, it turns into square root of 16 times 5, or square root of 5. So there's a 5 on the outside, so that minus 5 stays there. Square root of 16 is 4, and a square root of 5, and this becomes minus 20 square roots of 5. And then the square root of 20, I can think of 4 and 5, square root of 4, square root of 5. So there's already a 4 on the outside. I multiply it times another 4, and then it's a square root of 5, and that would give me 16 roots of 5. Now, this is considered a like term. The root 5 is like the variable, the root 5 is like the variable, the root 5 is like the variable. 9 minus 20 would give me negative 11. Negative 11 plus 16. Oops, Mrs. Kendall's got a boo-boo here. Nobody raised their hand and told me. What is the square root of 4? It's not 4, it is 2. So let's fix that. So that makes that 16 turn into an 8. So now back to this. 9 minus 20 is negative 11. Negative 11 and 8 makes negative 3 roots of 5. Sorry about the boo-boo, guys. Okay, that's adding and subtracting. Foiling is going to be the same as we've done before. We're going to do our first, our outsides, our insides, and our last. And on Friday, we talked about we multiply outsides, and then we multiply insides. Okay, so multiply outside by outside, inside by inside. So root 3 times 5 roots of 3 would give me 5 roots of 9. Root 3 times negative 4 roots of 2 would give me negative 4 roots of 6. Insides, I would get positive 5 roots of 6. And the last, I would get minus 4 roots of 4. Now, simplify anything that you can. I can simplify square root of 9. It becomes 5 times 3. I can't simplify the root 6's, so they stay the same. I can simplify a square root of 4. That's 4 times 2. So if I rewrite this, this is going to be 15. And these are like terms here in the middle. Plus 1 root of 6 plus 8. And I guess my final answer, oops, not plus 8. I am being silly today, aren't I? Minus 8. So that means I'm going to have 7 plus 1 root of 6. Okay, so now, next one. These are special types of factors. I'm going to start to introduce the word conjugates. And I want you, oh my goodness, I can't spell. The word is conjugate, but I spelled it incorrectly. C-O-N-J-U-G, conjugate, A-T-E. They're conjugates because watch what happens when you do the insides and the outsides. So when you do your first, you get the square root of 25, which hopefully you guys can see is 5. When you do your outsides, you get negative square root of 15. When you do the insides, you get a positive square root of 15. And when you do your last, you get minus square root of 9. This turns out to be 5. Oh, they cancel each out in the middle. Subtract 3. My answer is 2. If you've used conjugates correctly, those terms will be canceling out. Okay, so on to this last page of You Try It. I'd like you to turn off the video and try A, B, and then you can turn the video back on, or you can try them all and work it out. So turn it off, try them by yourself. Okay, so remember for the adding and subtracting, we simplify and then we add. So simplify, add, / subtract. Okay, so I have square root of 9 times a square root of 3 for 27, or 3 square roots of 3. For 12, I have square root of 4 times the square root of 3. That would give me plus 2 square roots of 3. And for 75, I have square root of 25 times square root of 3, which would be subtracting 5 square roots of 3. They're all the same roots, so they're like terms. 3 plus 2 is 5. 5 minus 5 is 0. I have 0, and if you want to write square roots of 3 behind it, but I'm just going to tell you it equals nothing, and that's how we're usually going to do it. Okay, so taking a look at B. For 32, I see that as the square root of 16 times the square root of 2. And I'm going back to my chart if I need to figure out what the largest square root is that would go into it. That's 4 square roots of 2. For 18, I got square root of 9 times square root of 2. That would give me minus 3 square roots of 2. And for 20, I have square root of 4 times square root of 5, which would be adding 20 square roots of 5. Combine like terms, 4 minus 3 would give me 1 square root of 2, and add on to 2 square roots of 5. That's as simple as it goes because you can't combine them if they're not like terms. Okay, so now on to the foiling. And for this foiling, we're going to do our first. And I'm going to have a square root of 15. I'm going to do my outsides, and I'm going to get minus 3 roots of 3. I'm going to do my insides. I'm going to get minus 10 roots of, minus 2 roots of 10. I was working ahead in my 2 roots of 10. And then I'm going to do last. And when I do those last, I'm going to get a positive 6 roots of 2. So now, 15 doesn't simplify, 3 doesn't simplify, 10 doesn't simplify, 2 doesn't simplify. That's my final answer. Square root of 15 minus 3 square roots of 3, subtract 2 square roots of 10, and plus 6 square roots of 2. It's as simple as it goes. Multiply these last ones. So when I do that, when I do my firsts, I get the square root of 25. When I do my outsides, I get positive square root of 30. When I do my insides, I get negative square root of 30. And when I do my last, I get minus square root of 36. The two middle terms cancel each other. So what am I left with? Square root of 25 is 5, minus square root of 36 is 6. My final answer is negative 1. Again, these terms are called conjugates, and tomorrow we're going to work a lot with those conjugates. So make sure that you understand it. Tonight's assignment is not on the sheet. I decided on the weekend to change it. Your assignment for tonight is a worksheet. And for that worksheet, they should be handing it to you. I already have it up, the answer key uploaded onto the classroom. Good luck, everyone, and I'll see you tomorrow.